Hello, everybody. This is a introduction to the gravity simulator. And the gravity simulator is going to show us these motions, and you're going to predict and calculate everything. Just a few notes. One, the gravitational constant is 1 in all of these, which makes the calculation easier. Things like placing a fixed star are really important. To pause the simulation before you continue is really important. And to place the planets at exact locations of these exact values. I'm going to show you how to do right now. Just a little point that there is this little instruction on the back, which I don't know why I bled on the back, but please summarize number 3. Please summarize number 3 really nicely. That summary is kind of the important point. Like, what's the point of it? I guide you through that for number 1, but for number 3, I'm asking you to do it on your own and to connect the dots. Number 3 is actually a little bit bigger. Please like make this gorgeous. You can do this on another sheet of paper. Please do it on another sheet of paper. You could also type it if you want to do screenshots and stuff like that. But make it just beautiful. Don't just do quick answers that are hodgepodge, like just written, like just briefly. Make it a complete piece of work is my huge request. So the gravity simulator link should take you here. If it takes you here, this guy does a lot of really cool codes. Check them out, but we're going to click on the free web version. And you should get here, and then you click on build, and it gives you a preloaded thing. Sometimes the preloaded thing is that. Sometimes it's this, like a triple star system, and we get a nice elliptical orbit. Sometimes it's this, all these guys orbiting together. That's kind of fun, right? So whatever you get, you're just going to, I mean, feel free to watch it for a moment, but you're going to click clear. And then you're going to click pause. Please click pause and see this star here. This is a star. These are planets. These are asteroids. These are just like a field of dust. And these are specific patterns that you can do. And these are different ways of making different orbits. And here's how you can change physics, and here's how you can change things. So what you're going to do is not change anything. The settings are perfect. You're just going to click on a star. You don't need to drag, just click. And notice I can move this. I don't need to do anything. I'm going to click right in the center, but you notice I missed. It's really hard to get it exact. So you're going to click on this button, the cursor, and click on it. And notice how its X, Y are not exactly 0, 0. So you're going to make them 0, 0. Its mass is 1,000, and you're done. Now you're going to click on a planet, and you can kind of click anywhere, but the whole point is we're going to click it here, and we're going to want it to orbit. So once again, you're going to click on the cursor and click on it, and you're going to change everything by clicking on advanced mode. You're going to want its heading to be 90, its speed to be 3, 4, 5, or 6. I'll make this first one 3. Its mass needs to be 0. Its mass needs to be 0 for all of these if you do multiple planets at once. If you don't do multiple planets at once, it doesn't matter. But once I get this one going, I put another one, and this one's still going because it looks so cool. So you don't want them to exert gravity on each other. In real life, planets do, which is really fun. Jupiter affects the Earth's orbit, et cetera, et cetera. It's really cool. But we don't want that. We want one orbit at a time, simple. Change the radius to 1. You don't have to, but I like doing that. It makes it smaller. You're going to change its x coordinate to 62.5, its y coordinate to 0. Just emphasizing this is x, 62.5, and y, 0. Obviously, these are x values here. Notice how I'm making this simple. We're just doing it in the x plane here. Notice if I click off, did I do everything? Oh, heading 90. If I click everything, it's now here. Now you notice it made a line because it moved it. And these are the trails off, trails on. So sometimes I do trails off to get rid of them, and then trails on to do it. And notice if I press play, it starts to move. I'm not going to show you what happens because you're supposed to figure it out. Ooh. Now notice though, as I uh, click on it, I can always pause the simulation at any time, and it shows me the speed. and it shows me the position. So the speed and the position I have. The speed is in meters per second. Gravitational constant is equal to 1, which I believe is here somewhere. That's so cool. Time, speed, you can change time. Gravitational constant, he set equal to 1. Just to make everything easier for his coding and for our math, it makes it easier. But you get the same result in terms of the shapes, which is really kind of fun. So you can click on a planet at any time. The key is to pause the simulator, and you get to click on a planet at any time, and it will tell you what's going on. So you can also delete a planet, delete, turn it off, turn it on, and then start over. Sometimes I like to make this radius smaller. Maybe you can make this radius like 3. Should probably have everybody do that. So make the radius of this smaller because I think that planet was going to hit it. It is in ghost mode, which are they'll go right through each other where they won't hit. So you're going to want to keep it in ghost mode, and it should orbit it in a nice ellipse. Cool. You should be able to tell me why and talk about its speed at its next tangential point, wherever that may be. Perfect. The whole point is that as these things move, and you can, by the way, you can normally drag, let them fly. Boom. This thing's such a fun simulator. You can pause it at any point, and oh, there that one goes. Oh, it's coming back. It's got an ellipse. You can figure out its exact position. Its exact position and speed. Notice that this one is going slowest. 654. And now it's speeding up again. Notice that that's its farthest point. That's its tangential velocity. Isn't that cool? Right? I can move it, which was actually a mistake. And I think there's an undo. I don't know if there's an undo. So if you do something, you might have to do it. I have not found an undo, to be honest. There should be, which is kind of unfortunate. But you can also change the color if you want, and the color of the line if you want to do that. I think I have made a mistake and I've moved my planet, so try not to do that. You can't drag it back in time, but you can make time go backward, which is kind of fun. And I'm trying to remember how to do that. Here we go. Time speed, you can have slower, faster, or reverse time. So let's reverse it and see what happens in reverse direction. I don't think that just makes time go backward in physics, which is kind of fun. It doesn't make you go back in your time, meaning it won't undo your mistakes. Again, I don't know if there's an undo button, so beware. All good, easy enough to start over. Just click X and it all starts over. Boop, done. Let me know if you have any questions. Pretty easy otherwise, and have fun. Again, make it look gorgeous, guys, and try to connect all the physics. This is like an ending. I do quizzes every once in a while, but this is instead of like a test, this is like a test to see how well you can analyze this using the simulator. Another last thing that's really important, please work on your own. Please work on your own. Do not collaborate with anybody else. In that way, it's similar to like a quiz or an in-class test. But you're going to work on this at home, in class. You're going to talk to me. I'm your friend. Ask me anything you want. And I'll give you an answer that will help you if you're stuck. Obviously, though, this is the only assignment where I'm going to ask you to work entirely on your own. See you in class, guys. See you in the universe. Enjoy and play with it on your own. It's a fun one.